This video introduces the topic of finding zeros. The learning outcomes are to use synthetic division to divide polynomials by x minus a, and to use the remainder theorem to determine the values of p of a, and to linearly factor polynomials using various theorems. The theorems that will help in factoring are the factor theorem that will determine if x minus a is a factor of the polynomial p of x, the rational root theorem, which helps decide possible factors for the polynomial. Finally, let's talk about the rational root theorem. It states that if you want to find possible zeros, get the factors of the constant and divide them by the factors of the leading coefficient. Our last division problem we had, which was 3x cubed minus x squared minus 176 divided by x minus 4, we found that the remainder was 0. This means that x is equal to 4 is a 0, and that x minus 4 is a factor of our polynomial. But what if I did not know that 4 was a 0? Where would we start guessing numbers? What numbers should we guess to see if they are zeros? To give you some possible guesses, the rational root theorem says that you get the factors of your constant, which is 176 in our case, and those factors are 1, 2, 4, 8, 11, 16, 22, 44, 88, and 176. And each can be either positive or negative, so we actually have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 11, plus or minus 16, plus or minus 22, plus or minus 44, plus or minus 88, plus or minus 176, that need to be divided by the factors of 3, our leading coefficient, and 3 has the factors of 1 and 3, but they also can be positive and negative. So our guesses for rational numbers that can be possible zeros will come to the following list of plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 11, plus or minus 16, plus or minus 22, plus or minus 44, plus or minus 88, plus or minus 176, because these are the factors of 176 divided by 1. But we can also have plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, plus or minus 8/3, plus or minus 11/3, plus or minus 16/3, plus or minus 22/3, plus or minus 44/3, plus or minus 88/3, plus or minus 176/3. These are the factors of 176 divided by 3. Okay, let's put this all together in this example. Find all zeros and factor the polynomial into linear factors, for p of x is equal to 6x cubed plus 19x squared plus 2x minus 3. So where should we start? We start with the rational root theorem so that we can have some possible guesses for our synthetic division. Factors of the constant, in our case the constant is 3, so the factors are 1 and 3. The factors of the leading coefficient is 6. The factors of the leading coefficient, which is 6, are 1, 2, 3, and 6. So our list of possible rational roots are plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 1 over 3, plus or minus 1 over 6. Notice that's the factors of 1. Notice that's the factors of 3, which was 1, and I divide it by each of the factors of the leading coefficient. The other set is going to be plus or minus 3 over 1, plus or minus 3 over 2, plus or minus 3 over 3, plus or minus 3 over 6. And then again, when we look at our list and we condense it, we can see that our final list would be plus or minus 1, plus or minus 1/2, plus or minus 1/3, plus or minus 1/6, plus or minus 3, plus or minus 3/2. Notice plus or minus 3 over 3 is the same thing as 1, and we already have that written down. And plus or minus 3 over 6 is the same thing as 1/2, and we already have that one written down. So we can narrow down our infinite number of guesses to just 12. So which should we try? Let's set up the synthetic division for our problem. Here's our small box. and the coefficients of our polynomial are 6, 19, 2, and -3. Let's see what happens if we pick the number 1. Put this into our synthetic division setup, bring down the 6, multiply 1 times 6 and write 6 under the next number, add, and we get 25. Multiply 1 times 25 and we write down 25 under the next number, and we add to get 27. We multiply 1 times 27, we write that number under the next number, and add, and we get 24. So was the number 1 a 0? The answer is no, since there is a remainder. The last number that we wrote down was not a 0. What we did find was a value of p of 1. In other words, if we would have plugged in 1 into our polynomial, we would have found that our answer would have been 21. So we need to try another number in order to find a 0. Let's try -3. Put this into our synthetic division setup, and we bring down the 6 and we multiply -3 times 6 and place the -18 under the next number, and we add. This gives us 1. We multiply -3 times 1 and put the -3 under the next number and add to get -1. We multiply -3 times the -1 and place a +3 under the last number and add. And there we can see that we get 0 at the end. This means that -3 is a 0, so that p of -3 is equal to 0. This also means that x minus a -3, or x plus 3, is a factor. We can now rewrite our polynomial of p of x is equal to 6x cubed plus 19x squared plus 2x minus 3 as 6x squared plus x minus 1 times x plus 3. We can use our knowledge of factoring quadratics to factor this quadratic 6x squared plus x minus 1, and we find the factors for that is 3x minus 1 times 2x plus 1. This means that our p of x is the same as multiplying x plus 3 times 3x minus 1 times 2x plus 1. This is the factor form of our polynomial. If we want to find the zeros, we can divide and multiply by 3 in this fashion, so that we get 3 times x plus 3 times x minus 1/3 times x times 2x plus 1. And we do the same for the last parentheses, so that we get 6, from the 2 times 3, times x plus 3 times x minus 1/3 times x plus 1/2. This is the intercept form of our polynomial, because if we set our polynomial equal to 0, we can see that when we set 6 times x plus 3 times x minus 1/3 times x plus 1/2 is equal to 0, we know that x will equal to -3 from the first parentheses, x will equal to 1/3 from the second parentheses, and x will equal to -1/2 from the last parentheses. This means that there are 3 x-intercepts, one at -3, 0, one at 1/3, 0, and the last one at -1/2, 0, and that the zeros of p of x are in the numbers of -3, 1/3, and -1/2. You may want to view the example videos for further practice, and this concludes this video.